Hi, this is Lori, and this is my homework for Paul McWhorter's Pico W course, lesson number 31. In this lesson, we're going to create a sensorless remote weather station with our Pico, and we're going to use the API Open Weather Map to get weather information for our location, and then we'll build a circuit with our Pico that will have some other components on it that we can use to display the information. So next up, I'm going to show you how I set up my circuit. So I have my circuit over here, so I'm going to kind of look away from the camera for a few minutes, but I'll show what I put together. So I just recently got a bunch of these ring NeoPixels, and I've been having a lot of fun working with them. And when I started to think about could I do something with my NeoPixels as part of the homework, I immediately thought about the wind, and using the NeoPixel as a compass to show the direction of the wind. So I'm going to use that. As you can see, I've drawn a little compass here for my NeoPixel, and then with the color that I use, I'm going to indicate the wind speed. So you'll see in the code that I have different colors for different amounts of wind speed, and then of course the one that's lit will be the direction of the wind. So that was one little thing I did because I was enjoying playing with the ring NeoPixels. And then I decided I have a breadboard NeoPixel down here, and this one's going to be used to show a color version of the temperature. I'll go ahead and use the SSD 1306 to display some information from the API about the weather where I live. I'll just point this down a little bit so you can see I have my my power here, and so I'm running independent of my computer. So we're all set up with that. So next up I'll show the code, and now that you've kind of seen the setup I have, some of this will make some sense. All right, this homework is far behind. Been traveling, and also I got kind of lost in this. Simply Brian, I think, talks about how you can start looking into things and get lost in it a little bit, and I definitely got lost in APIs and looking around at all the APIs that were available and all this cool data, and so I finally stopped and said I just need to do this homework. Those are all my excuses for why I'm so late. Well, we're going to import everything we need. And I showed some NeoPixels before, I think, importing the NeoPixel library to use them. They're pretty simple to use. And I took my Wi-Fi code, put it all into a function, and I showed that in my last homework. And now I've went ahead and put that in a separate file called Connect Wi-Fi. So all that information is in a separate file now. And everything else we need to get started, so we're familiar with all that. And then this is just what it takes to set up the NeoPixels. So I have the one NeoPixel sitting on the breadboard for the temperature. So it's just only a single NeoPixel and connected to pin 10, setting the brightness and initially setting it so it's off. Then same thing for the ring. That's got 24 NeoPixels in it. And it's on the other PIO, so there's one on 0 and one on 1. So that's how these work. You can have two of them at a time, and also just making sure it's all turned off when we start. Then we'll initialize the I2C bus we'll need and the 1306 display. Then I went ahead and made this really rather large function to get the weather information. And I made it so that the location that you're choosing to look up is something you can ask for, but I have it set to where I live in Quakertown, Pennsylvania, United States. So you could change that to your location. And then it goes through and does all the steps that you need. And I'm just creating a dictionary as I go along of all the information, because I figured at some point I'm going to want to pull up, pieces of this and display it. A lot of it on the 1306 display, but of course some of it on the NeoPixels as well. So I decided just to kind of put it all in a big dictionary and then return the dictionary from the function, since we're going to want to update the weather every so many minutes or hour or whatever it might be. If you were actually running this for a long period of time, you'd pick some particular time and you'd just do this get weather function whenever you wanted an update. So it just creates this big dictionary where it's all the things that Paul taught us in the course of how to get the sunrise and where we're from and the temperature, humidity, pressure, the conditions, the text fields for those conditions. And I did a lot of F strings to create some nice prints that would go to my 1306 display. So I kind of took care of all of that and then returned that dictionary out of the function. So just to kind of make it a little more neater and tidier, that was the only reason. Then we'll go ahead and connect using my Connect Wi-Fi. Then we'll get the first reading of the weather, because the first time through, I want to go ahead and get the information so that I can turn on the pixels. So you can take a look here with the NeoPixel for the temperature. We're going to go ahead and grab the temperature out of my dictionary. And you can see if it's less than 32, then I'm going to make it blue. If it's between 32 and 50, I'm going to make it kind of that, I forgot what we call it, a teal kind of color. And then 50 to 80, I made that green, because that's temperatures I think are suitable for outdoor activity. And then anything above 80 is red for me. And so that's what I chose to do. But clearly you could pick all different kinds of colors. And once you set that, then you'll show the color on the NeoPixel on the breadboard. And then the same idea for the wind and speed on the NeoPixel ring. But what you need to do is we have 24 of those. So kind of each NeoPixel represents 15 degrees for the 360 degrees. So I took the current wind direction, which is provided in 0 to 360 degrees, divided it by 15, and then that became the pixel that was going to get lit. That's maybe not ideal, because you kind of have to go over the limit. So if it's 14, it's still going to show directly north rather than something in between. But you could fine tune that and make this more complicated, but that's how I decided to do it. So again, then when we know which pixel we're going to turn on. So we're going to use the integer of this calculation, turn on that particular pixel. But then what color we're going to turn it on depends on how fast the wind is going. And so if it's 5 miles per hour or less, then I have it as green, as a very gentle wind. And then if it's between 5 and 15 miles per hour, well, that's kind of an orange. And then if it's over 15 miles per hour, then it'll be red. So again, just a choice of what kind of colors to use, but you can play around with that quite a bit. And then I'm still using this idea that, we don't want to read the API all that often. So I'm kind of using the blink without delay concept that we've used a little bit before. And so I'm initializing a previous time. And then if the difference between the previous time and the current time is not more than a minute, then it's not gonna go through and do a new read. So you can see it here. It's gonna get the weather again if it exceeds that. It will also print to the OLED that it's getting new data for our location. So I thought that was nice. So you could kind of tell, is it updating? It'll print that to the OLED, and then it'll reset the previous time. And then it will go ahead and reset or re-update the colors for the temperature and update the wind and speed on the ring. And no matter what, it's always going to be cycling through 3 different screens of information. So this is outside of this if statement. So while it's going through this while true, it's going to keep rotating through these 3 screens on the OLED. So I'll prepare the first one, and it'll be the conditions at my city. It'll give the temp, the wind direction, and speed. And it'll go ahead and show that, and it'll sleep for 10 seconds. So that's on the screen for about 10 seconds. Then it'll go to the next screen. So we'll clear it out, and we'll put some more information, the date and the time, humidity, the pressure, and the text for the condition. We'll show that, sleep for 10 seconds. And then we'll do one more screen for more info. For our city, we'll give the sunrise and sunset. So, all that information that we could have printed. There's probably some more stuff I should have put on here, but it was just an idea of trying to figure out how to make it do 3 screens and rotate through them, but only update the new weather information every so often. And of course, like in real life, I think I would want this to be more like 5 minutes. Right now I have it set for, about a minute, I guess. Every minute it's going to go out and get a new one. So that's kind of how I did it. And at first I thought I might do some sort of menu so you could flip between the screens, but I kind of like this idea. It just sort of rotates through them. So that's how it works. All right, so now it's time to see it go. Okay, so I'm going to go ahead and plug it in here and get it started. Hopefully it's going to run. There we go. I think we can see everything. So it's getting started. It's getting on the internet. It went ahead and did it. Now it's a little hard to see this particular one, but maybe if I put my finger by it, you can kind of see it's green. And you can see the information on the screen is starting to rotate. And it's a little far away, but I'll zoom in a little bit on it. So you can see here's the direction of the wind, and it's very light right now. Earlier we were having a storm, so it actually got to that orange color. I'll go ahead and try to zoom in on my screen, see if you can kind of see how it looks there. So that's the first screen. That's the second one. So you get the pressure and humidity, and mist is the conditions right now. And here's the sunrise and sunset. And I think pretty soon it's gonna go to try to get some new data. Yeah, a minute's gone by. It goes through the screens 3 times, and then it's gonna get some new data. And there we go. So the wind direction is 70 degrees, and it's 4.6. So let's just look up there. And you can see, yeah, the 60-degree spot is marked. And it's green. So, yeah, and you can see the other pixel there. So that's how I decided to do it. That's my homework. And Paul, this has been a fascinating series of lessons. I really do appreciate you sharing your knowledge with us on this. And I want to thank you guys for watching.